Morning, all of you. Today's lecture we will discuss the conformal mapping of some functions sin z, cos z, z square. Right? Discuss thus the mapping. Thus the mapping W equal to sin z. W equal to sin z. Let's see what they given. W equal to sin z. Right? Now let z equal to x plus iy. Right? So its image f of z, which is W equal to q plus iv, right? It is clear. Then you substitute q plus iv is equal to sine of x plus iy. Okay, since we have sine of a plus b, so which is sine a cos b plus cos a sine b, right? It is clear. So then this expression becomes sine a cos b, right, plus cos a sine b, right? Now, from the hyperbolics, that means cos iy is cos hy, right? Then sin iy, so which is equal to I sin hy. So it is clear. So then, so this becomes sin x cos iy plus cos hy, sorry, plus I cos x sin hy, right? It is clear. So this is u plus iv. U plus iv. Then compare real and imaginary parts. So, and comparing real and imaginary parts. So what is u? Here u is sin x cos hy. And what is v? V is cos x sin hy. Right? Now from this, what is sin x? Sin x is nothing but u by cos hy. Right? So from this, what is cos x? V by sin hy. Right? Up to this, okay. Then we have a trigonometric function, so which is sin square x plus cos square x is equal to 1. It is clear. Then, so u by cos hy whole square plus b by sin hy whole square, so which is equal to 1. It is clear. Thus, then see, after simplification, it is u square by cos h square y plus b square by sin h square y, so which is equal to 1, right? Then see case 1. If y equal to constant, y equal to constant, so that is y equal to some a, y equal to some a, the line parallel to x-axis is mapped to what you have to find. So if we take y equal to constant, so that line is mapped to w plane, so that you have to find, right? See, if y equal to some constant, so then this equation becomes, then this expression becomes u square by cos h square a plus b square by sin h square a, so which is equal to 1. Is clear? So this is of the form, see, cos h square a and sin h square a, both are some constants, that's all. both are some constants. That means it is of the form, see, this is of the form, of the form this is of the form x square by a square plus y square by b square is equal to 1. So this is actually nothing but, so is an ellipse. This is an ellipse because cos h square a sin h square a both are constants. So from this it is clear that if a straight line, a straight line y equal to a, so that is a line parallel to x-axis in z plane, in z plane is mapped to, is mapped to ellipse, ellipse in w plane. So from the case 1, so it is clear that a straight line y equal to a in the z plane is mapped to ellipse in the w plane, right? So we can figure out it is, see, this is our z plane, right? So a line parallel to x-axis, see y equal to b now. So this is a line parallel to x-axis, x and y. This is our z plane. Okay. Now, so what is w plane? This is mapped to, mapped to. So it is a w plane. So what is this? It is an ellipse, right? So this is your w plane. That means here u p. So it is w plane. Okay. So that means a straight line y equal to b, that is a line parallel to x-axis, the z plane is mapped to ellipse in the w plane under the transformation w equal to sin z. That we have to conclude. It is clear. Then see, what is u? U, there is sin x cos hy, and here is v equal to cos x sin hy. Right? Now from this, what is cos hy? Which is u by sin x. Right? So from this, it is sin hy. So which is v by cos x. Right? So we have hyperbolic identity. So which is cos h square y minus sin h square y. So which is equal to 1. Okay. Then cos h square y is nothing but u by sin x whole square. U by sin x whole square minus v by cos x whole square. So equal to 1. Right? So that means it is u square by sin square x minus v square by cos square x equal to 1. Okay. So then, so this is our equation. See, now case 2. If x equal to some constant b, so x equal to some constant b. So that means a line parallel to, a line parallel to y axis. So this is mapped to w plane that you have to find, right? Now if x equal to b, so then our equation becomes u square by sin square b minus v square by cos square b, so which is equal to 1, right? It is clear, right? So then, so see, this is of the form, this is of the form, now it is x square by some a square minus y square by some b square is equal to 1. So it is called an hyperbola, so which is an hyperbola. So that means if a line parallel to y-axis in the z plane, if a line parallel to if a line parallel to uh, y-axis in the z plane is mapped to w mapped to hyperbola hyperbola in the w plane, the w plane, right? You can figure out how it is. See, this is our z plane, a line parallel to y axis, x equal to b, right? So x, this is y, but z plane is mapped to the hyperbola. B, this is w. Okay, so that means if a line parallel to x-axis, so that is mapped to ellipse in the w plane. If a line parallel to y-axis, that is mapped to hyperbola in w plane under the transformation w equal to sin z. Under the transformation w equal to sin z. That is our conclusion of the problem, right? Next one, discuss discuss the mapping. Discuss the mapping w equal to cos z. Cos z. That means see, w is nothing but u plus iv na. U plus iv. U plus iv is equal to cos of x plus iv. Cos of x plus iv. Right? Which is equal to see cos a plus b is nothing but cos a cos b minus sin a sin b. Right? So which is equal to cos a cos b. See it is cos iv na. Cos iy is nothing but cos hy. Right? Sin iy is nothing but I sin hy. Right? Therefore, it is cos hy minus I into sin x sin hy. Okay. Now here is u plus iv. What is u? U is nothing but cos x cos hy. What is v? Here is minus sin x sin hy. Right? Up to this, okay. Then what is cos x? What is cos x? Cos x is nothing but q by cos hy. Now here is what is sin x? It is minus v by sin h. Okay. So from the trigonometric identity, what is that identity? Sin square x plus cos square x is equal to 1. Now substitute q by cos hy whole square plus minus v by sin hy whole square, which is equal to 1. Now we simplify. That means it is see u square by cos h square y plus here is minus whole square is positive na. It is sin h square y equal to 1. Okay. So then now case 1, if y equal to some constant a, y equal to constant, so that means a line parallel to x axis, a line parallel to x-axis. Then our equation becomes u square by cos h square a plus v square by sin h square a. So which is equal to 1. So this is equation. This equation is called ellipse. So in the last problem we have seen, right? So that means a line parallel to x-axis, a line parallel to x-axis is mapped to ellipse in W plane. Right? It is clear. And next one from the hyperbolic. That means u equal to the cos x cos hy. So what is v? Sin x sin hy minus sin x sin hy. Okay. Then uh, from this it is cos hy equal to u by cos x. Okay. So from this it is sin hy equal to minus v by sin x. Then we have hyperbolic identity cos h square y minus sin h square y, which is equal to 1, right? That means u square by cos square x minus b square by sin square x equal to 1, right? Now here case 2. Case 2 is what? If x equal to some constant b, so let it be b. That means x equal to b. That means a line parallel to y-axis. Line parallel to y-axis. A line parallel to y-axis. That means it is u square by sin square x. Na? That means sin square b minus v square by cos square b, which is equal to 1. Okay. No. Is it cos square b is sin square b. What is this equation? So this equation is a hyperbola. Hyperbola. Right? Now a parallel to parallel to y-axis in z plane is mapped to hyperbola in w plane. Right? It is clear. Under the transformation, which transformation? That the transformation w equal to cos z. Right? That is our conclusion. Then next one, see, discuss the mapping. Discuss the mapping w equal to z square. Just the mapping w equal to z square. Okay? What is w? U plus iv. U plus iv. So which is equal to x plus iy whole square. So which is equal to x square plus iy whole square plus 2x into iy. That means a plus b whole square formula. X square minus I square is 1 minus 1 na? Plus I square is minus 1. Therefore it is minus. Plus 2ixy. Okay. So this is u plus iv. Now what is u? X square minus y square. What is v? 2xy. Right? Now see case 1. If y equal to a, some constant a, constant a. That means a line parallel to x-axis, right? Now, if y equal to a, then it is u equal to x square minus a square. Here is 2ax, right? So from this, it is x equal to v by 2a, right? So from this, it is x square equal to u plus a square, right? Then see, it is you replace this x in this. That means v by 2a whole square equal to u plus a square, right? Then v square equal to, what is v square? V square equal to, it is 4a square into u, u plus a square, right? It is clear? Yes. So what is this equation, right? So see, this is of the form y square equal to 4 into some constant into u minus some constant. It will be some c1 or something minus c1. So what is this? This is a parabola. This is a parabola, right? So that means this is a parabola with vertex minus a square comma 0, right? And at origin focus at origin is symmetric about the real axis. So here real axis is nothing but u axis. Okay, that means see, so our what is our jet plane? This is our jet plane, right? Jet plane x, y. What we are considered, y equal to a, y equal to a. So this is mapped to, y equal to a is mapped to what is minus a square comma 0. So that means see, this is minus a square comma 0 and symmetric about real axis, right? Is clear. So this is our ZW plane, right? Now case 2, if x equal to some constant, x equal to constant, so that is x equal to some b, x equal to some b. So now what is u? U is nothing but x square minus y square. What is v? 2xy. Now we are taking u equal to x equal to b, right? B square minus y square. Here is 2by, right? From this y equal to b by 2b. So from this y square equal to b square minus u, right? Now you replace this in this. That means it is v by 2b whole square, so which is equal to b square minus u, right? So it is v square by 4b square, b square minus u, right? Now which is equal to, say, b square equal to 4b square into b square minus u, right? Now if we take minus common, minus 4b square into u minus b square, right? So what is this equation? So this is of the form, see, how it is, how it is, v square equal to minus 4b into minus b square, na? So this is of the form y square equal to minus 4a to uh, x minus some b, right? So what is this? This is also a parabola, right? So this is a parabola, this a parabola with vertex b square comma 0, focus at horizon, right? Symmetric about real axis, symmetric about real axis q, right? Now, right? This, right? So this is jet plane. So under jet plane, so this is what parallel to the x equal to b means that is parallel to y equal to b, right? X. So this is mapped to our w plane is that b square comma 0 na, it is b square comma 0, right? So q b w plane. This is jet plane, right? You can add these two cases in one figure. That means see, this is our jet plane for suppose. This is our w plane. See, when the line parallel to y, so which is x equal to b, right? When a line parallel to x axis, it is y equal to a, right? This is your jet plane x, y. So here is see, when a line parallel to x axis y equal to a is mapped to parabola, right? This is minus a square comma 0. So when line parallel to y axis x equal to b is mapped to, right? This is one parabola b square comma 0, right? The one parabola. So these two intersect at these points, right? So this is w plane. Right? It is clear that now what is the conclusion? So if a line parallel to x axis, that is y equal to a, is mapped to a parabola with vertex minus a square comma 0, and if a line parallel to y axis, that is x equal to a, is mapped to is mapped to a parabola with vertex b square comma 0. So in the w plane, in w plane, so here in w plane, right? So under the transformation, so which transformation? W equal to z square. Okay, it is clear.